Section 9.1, Inferences for Regression, Video 7. As we wrap up this section, we need to talk about the conditions for a simple linear model. In other words, visually speaking, what should we be on the lookout for in a scatter plot before we decide whether or not to proceed with a simple linear model? Well, namely, the conditions for a simple linear model are straightforward. Apparently, I've got some erasure here. My apologies. For each value of x that we observe, the observed values of y are approximately normally distributed around the predicted value of y. In other words, the errors, aka the residuals, are normally distributed with the mean of 0. Now what the heck does that mean? Here's what that means. Let's say that we have a prediction line here that predicts our y values based on our x values. And we pick a specific value for x, which we're going to call x star. That's going to be a notation that shows up later. So what does it mean to be what does all this mean? That means that we have a predicted value. This is our predicted y value for x equals x star. Because this is the y that's above this x. So what does it mean for the observed values of y are approximately normally distributed around the predicted value of y? Well, let's say that this dot plot, I don't know if you can see it clearly, this dot plot represents the observed y values for that specific x value. In other words, let's go back to the bills and tips. If we had a bill of $40, let's say that this is a dot plot representing all the different tips that we got. What it means for the observed y values to be approximately normally distributed around the predicted y value means, number one, this should be approximately a bell curve, which it approximately is. So imagine this bell curve of y values being all the points that are living above this x star. So these two dots would be up here, these three dots would be here. What this is saying is that for an x star, the y's that we observe need to be approximately normal and centered at this point. So if you can kind of imagine this being a dot plot sitting above this x star value and coming out into a third dimension, then that's what it means for observed y values to be approximately normally distributed around the predicted value of y. So a few of them out here, but the closer we get, the more we have, and then they get real clustered here. It's kind of hard to see in 2 dimensions here because we're thinking about a dot plot coming upwards. If you look in your book on page 583, they attempt to draw a picture of some bell curves coming up from the page to show you what they're representing. So, that's what we want to happen. So, how can we see when that doesn't happen? Well, the same things as before. Stuff can go bad. There are 3 things that can go wrong. 3 things we should look out for. Thing number 1, nonlinear patterns. In other words, the dot plot is curved. So, if we had a dot plot that kind of looked like this, that's not very linear. Looks more quadratic, more parabolic, if you will. Second thing to be on the lookout for, increasing variability. One thing I didn't mention about the dot plots or bell curves living above each x value is that the standard deviation for them can't grow as you keep going. In other words, however far it's spread out on one x, it should be about that spread out on all of them. It doesn't have to be exactly the same, but it can't just increase over and over and over. So for example, let's say that we have a line of best fit, and then we have some dots that early on stay fairly close to the line, but the further out we go, they start spreading out more. It's almost as if you were to put a line that served as a ceiling for these and a line that served as a floor. The further out you go, the further out those lines get. So in order to avoid that, you really want the lines defining the tops and bottoms of your scatter plot to be fairly the same distance apart from each other as you move along, somewhat parallel to the line of best fit. And then the third thing, and this shouldn't surprise you, outliers. If you have a line of best fit and a bunch of points that are kind of staying close to it, and you got this point up here, yeah, you don't want that. So if you see an outlier or increasing variability or a nonlinear pattern, then that's a pretty good indicator that you shouldn't consider a simple linear model. And remember, the problem with outliers is that if they are so far out you have to zoom out to see them, then the rest of the scatter plot looks a lot more closer than it is, and it might give the false impression that there is a linear association.